Today we're going to talk about what is a p-value, what it is not, and how to find it. First, here are some important reminders that a p-value is not the probability that HO is true. So a lot of people have the habit of saying that, and that's only good to infuriate a good statistics professor. So it's not that probability. One way to never get the p-value wrong, meaning never get your decision wrong, is to follow this rule. If the p-value is smaller than alpha, you reject HO. I put a quote by Keith Bauer here, which might help you remember. If the p-value is low, HO must go. Also, the p-value is the quantity of evidence against HO. But keep in mind, the smaller the p-value, the larger the evidence against HO. So the p-value has to be very small in order to have strong evidence against HO. And finally, the p-value is a probability, so it cannot be larger than 1. So these are common mistakes students make, which you want to avoid. Now, let's see how we find the p-value. Let's say we have a t-distribution, and HA for this example is mu is greater than 10. Note, it's critical that you know HA, otherwise you cannot find the p-value. A lot of people don't know that or forget that, and then they simply assume that the p-value is whatever area is towards the tail, and that's not correct. You need to know HA. More specifically, you want to look at this sign on HA, and this sign is sending us to the right of the test statistics. So here's the test statistics, and we have degrees of freedom 20. So let me draw a t distribution shape. This is a t number line. The t resembles the normal shape. The center of a t is 0. And note, I don't have any critical value here. I simply have the test statistics. So I'll just write it somewhere, and I'll say test statistics 3.4. Therefore, the p-value is going to be the area to the right of the test statistics, because HA points to the right. That's why the p-value is the area to the right. Now, how big is this area? Well, we need to go to the t-table. So in the t-table, our strategy is to locate the degrees of freedom row and squeeze this number, the 3.4, between two numbers. So our degrees of freedom is 20. So let's take a look at the t-table. So here is degrees of freedom 20. I highlighted it slightly. My cursor is right there. Now I'm going to follow this row at the bottom of this blue bar until I can squeeze 3.4 between two numbers, and I am right here. So 3.4 is between these two. Our job now is to go all the way up and take a look at these two numbers, 0025 and 001. The p-value is right between here. Now, it is not quite correct to say that the p-value is between 0025 and 0.001. That's because the p-value in this case is going to infinity, so it is more I would say suitable to say that the p-value is less than 0025, because our HA is sending us to the right. So let's get back to our document, and we're going to say that the p-value is less than 0.025. 0.0025. This shows HA direction. Okay. Now let's take a look at the second example where we still have a t distribution, but this time HA is sending us to the left of the test statistics. Note, we still have the same test statistics and the same degrees of freedom. So let's see both on the screen. I'm going to draw that shape again. Here's the center of it, 0. But this time, HA is sending us to the left. However, I still got the same test statistics of 3.4. So here's where a lot of students make mistakes, because some students think, maybe many students think, that they should actually go to the right because there is a tail near our test statistics. That is incorrect. You have to go in the direction shown by HA, and therefore we go to the left. So this p-value is going to be a giant because we are flying over, almost over the whole shape. Now let's see what happens now. Back to the t-table. Same 20, row 20, and same test statistics, 3.4, and we go up again, and the p-value is somewhere between the 0.0025 and the 0.001. However, HA is sending us to the left. So how do we find this p-value? Let's think. The whole area is 1, so the area to the left must be 1 minus the 0.0025. So let's see what happens there. This whole area here is 1 minus 0.0025. Okay, so, and this is going to give us what the p-value is at least. Note, why at least? It's because we passed this 0.0025 a little bit. We are between that number and 0.001. So we are a tiny bit to the right of 0.0025. So the p-value is at least 1 minus this 0.0025. So back. Here we're going to get 9,975. Now, that's not the p-value. The p-value is at least that. It's not precisely that. Okay? Now, we're going to look at a z-table p-value. And we have our z. We have our z test statistics. HA says mu is different from. So we know now from looking at this sign that this was a two-tail test. And by the way, above we did the t's, and we can see that the first example was a one tail to the right. We go to the second example, one tail to the left, and the third example, two tails. So here's the z shape, and the test statistics had two tails, so here's one tail, and here's another tail, the center 0, and we got a test statistics of 2.1. So note that the shaded area is half of alpha. Okay, half of alpha. We don't need to know alpha so far. Actually, we don't need to know alpha at the moment. We just need to find the p-value, and then we compare it to alpha. So let me see if I grab some color here, and I'm going to assume that my test statistics somewhere here, and this is 2.1. let's take a look at HA. HA is saying 2 tails. So because it is 2 tails, then I also have a negative 2.1 on this side. No, because it is 2 tails, then the p-value is the area starting at the test statistics and going to infinity. Here's a piece of it. We have another piece of it on the other side. Now, because the normal distribution is symmetrical, then all I need is to find one of these pieces and double it. Okay? So we could go to the z table on the positive side. That would be a lot more work because we don't really have to go to the positive side. We can simply go to the negative side, and whatever number we find there is this red tail here. So once I find this, I just double it. Why don't I want to go here on the right side? Well, then because I have to do 1 minus a number, I don't want to waste time doing that little subtraction. So I just go to minus 2.1 and see what number is there. So let's go to the t table, and we're going to take the negative of it. So minus 2.1, and we are right here. The little area I shaded is actually 0.179. So we'll go back here and we'll say that this little area is 0.179. Now, because there are 2 tails, I want to double it. So the p-value is going to be the p-value equals 2 times 0.179. Okay? And now we're going to find a spot here to say p-value equal 0.358. 0.358. So this is the p-value, and we find out what alpha is now. And if alpha is 0.5, then the p-value is less than alpha, we reject HO. If alpha is 0.01, then the p-value is greater than alpha, then we don't reject HO. Note, for alpha equals 0.5, we are going to reject HO because the p-value is less than 0.5. However, for alpha equals 0.1, we fail to reject HO. We fail to reject HO because the p-value would not be less than alpha. If you have p-values for the F distribution and for the chi-square distribution, the idea is the same. Here would be the chi-square distribution, and you take the degrees of freedom for the chi-square, which is k minus 1. Go to the chi-square table, squeeze your test statistics between 2 numbers, and state the p-value. If you're looking for p-values for the F distribution, the same idea, but the F is a little different in the way you find the p-value. So here's the test statistics. Now the F distribution has 2 degrees of freedom, the numerator and the denominator. You need both. Then you go to the F table, the numerator degrees of freedom on the column, and then the denominator degrees of freedom on the row, and you go to the intersection of these two. You may find a box with several numbers, and you squeeze your test statistics between those two and state the p-value. Note that it's important you remember this. Only the Z normal distribution allow you to state a precise p-value. So only in the Z can you say something like p-value equals 0.358. On the T distribution, you cannot do that. You always have to state that the p-value is less than, the p-value is at least, or you could say that p-value is greater than. And that's because the T table has only a few of the numbers on the tail that you're looking for. Okay, and it's very unlikely that you get one of these numbers as your test statistics. You may not get them in a long time. So you're going to get a number that's to the right of it, to the left of it. Therefore, the p-value is going to be less than somebody up on the column heading. Well, I hope this is helpful, and I'll see you next time.